So number 23 says, based on the table, which combination can be used to create a tessellation? So we're given a list of some regular polygons, we're given some interior angle measures, and then we're given some combinations to consider to see if we can find one that would tessellate. So remember, when we're talking about tessellations, what we're looking at is, could we get a group of figures to rotate around a point or fill in around a point without leaving any gaps? So as an example, if I was looking at the dot I have here, I could draw 4 squares off that. There's 2, there's 3, there's 4. I could draw 4 squares off that point. And what I'll notice is that I get 4 90-degree angles. And those 90-degree angles all add up to 360 degrees. So in order to tessellate, I need to get the interior angles to sum to 360 degrees for that to work. So looking at these combinations, I want to see which group of interior angles measures up to 360 or adds up to 360. So for the octagon here, I've got 135 degrees and the hexagon's 120. If I added up those interior angles, I get a total of 390 degrees, which is 30 more than 360, so it's not going to tessellate. We're going to get some overlap. For a second combination, again, I've got 2 octagons, and then I've got 90 degrees for a square. So if I add those up, I get 270 plus 90. That gives me 360 degrees. 360 degrees is what I want because I need it to go all the way around the point. So B is my answer.